Okay, only 4 students attend the class. Let's wait for a while. Okay. Okay. Last time we have learned the physical layer. So we will review these points. First, what is the baseband transmission? Baseband transmission, that is the basic digital modulation techniques. For example, most straightforward form is to use a positive voltage to represent 1 and a negative voltage to represent 0. For example, there are these baseband transmission schemes. Then Manchester coding is widely used in the Ethernet. Manchester coding is widely used in the Ethernet network. Manchester coding. Okay. Then the second transmission schemes is passband transmission. Because an arbitrary band of frequency is used to pass the signal. The absolute frequency value does not matter for capacity. We can take a baseband signal that occupies 0 to B Hz and shift it up to occupy a passband of S to S plus B Hz without changing the amount of information that it can carry, even though the signal will look different. Okay, passband transmission, we have a amplitude shift keying, frequency shift keying, phase shift keying. We also called ASK, FSK, PSK. In ASK, two different amplitudes are used to represent 0 and 1. In ample with a non-zero and a 0 level is shown in the subfig B. Usually more than 2 levers can be used to represent more symbols. Similarly, with FS key, frequency shift key, 2 or more different terms are used. The example in subfig C, subfig C use just the 2 frequencies. The simplest form of PS key. The carrier wave is systematically shifted 0 or 180 degrees at each symbol period. Now we will review the division multiplexing techniques, including frequency division multiplexing, time division multiplexing, and code division multiplexing. Multiplexing schemes have been developed to share lines among many signals. That means many signals can be transmitted in a single line. So it helps to improve the efficiency of the physical line. FDDM, frequency division multiplexing, takes advantage of passband transmission to share a channel. It divides the spectrum into frequency bands, with each user having exclusive possession of some band in which to send their signal. The second scheme is time division multiplexing. With TDM, users take turns in the round-robin fashion, each one periodically getting the entire bandwidth for a little burst of time. An example of TDM is shown in this figure. Usually, each user occupies a narrow time slot. Bits from each input stream are taken in a fixed time slot and output to an aggregate stream. This stream runs at the sum rate of individual streams. For this to work, the streams must be synchronized in time. Small intervals of guide time analogous to a frequency guide band may be added to accommodate small timing variations. TDM is used widely as part of telephone and cellular networks. TDM includes basic TDM and STDM. STDM means statistical time division multiplexing. The prefix statistical is added to indicate that the individual stream contribute to the multiplexed stream not on a fixed schedule, but according to the statistics of their demand. STDM is packet switching by another name. So packet switching is based on the idea of STDM. The third one is CDM, means code division multiplexing. It is a form of spread spectrum communication in which a narrowband signal is spread out over a wider frequency band. This can make it more tolerant of interference, as well as allowing multiple signals from different users to share the same frequency band. Because code division multiplexing is mostly used for that purpose, is commonly called CDMA. It allows each station to transmit over the entire frequency spectrum all the time. Multiple simultaneous transmissions are separated using the coding theory. Each station is assigned a specific tape code or tape sequence. For example, tape sequences is assigned for these 4 stations A, B, C, and D. Each bit time is subdivided into M short intervals. These M short intervals called tape sequence. Typically, there are 64 or 128 chips per second per bit. To transmit a 1-bit station sends its tape sequence, while to transmit a 0-bit, it sends the negation of its tape sequence. No other patterns are permitted. For example, A has this tape sequence 000110111. Here, -1, -1, -1, -1 means 0. +1 means 1. -1 means 0. +1 means 1. So the tape sequence of A is 0001111. Then we have this equation. When using the symbol S to indicate the M-chip vector for station S, then S bar for its negation. All chip sequences are pairwise orthogonal, by which we mean that the normalized inner product of any 2 distinct chip sequences S and T is 0. So it is known how to generate such an orthogonal chip sequence using this method, Walsh codes. Then if S inner product T equals 0, then S inner product T bar is also 0. But S inner product S equals 1. And S inner product S bar equals -1. That will make this make the key of the CDMA to be able to extract the desired signal while rejecting everything else as random noise, because we have S inner product S equals 1, S inner product S bar equals -1, but S inner product any other chip sequence is 0. If T is not S, then S in the product T is 0. That is why CDMA can reject everything else as random noise. Then about a public switched telephone network, we should understand the switching, the circuit switching and packet switching. Subfigure A shows a poorly interconnected network. It is not practical for large-scale network. So centralized switching or two-level hierarchy switching networks was devised. PSTN means public switched telephone networks. The company run a wire to each customer's house or office, make a call, a customer would crank the phone. Then the operator would then manually connect the corner to the calling. That is an old method. The basic idea of the telephone switching. This figure shows a typical circuit route for a long-distance call. Usually, a telephone system consists of 3 major components, including local loops, trunks, switching offices. Then the fourth division multiplexing scheme is wavelength division multiplexing. WDM wavelength division multiplexing is invented around 1990. It supports a very large capacity of physical channel. So it is widely used for worldwide internet connection. Then about the switching, we will talk about circuit switching and packet switching. There are 2 different switching techniques. We know the traditional telephone system is based on circuit switching, but packet switching is beginning to make inroads with the rise of VoIP technology. Both kinds of switching are important. Conceptually, when you and your computer places a telephone call, the switching equipment within the telephone system seeks out a physical path all the way from your telephone to the receiver's telephone. This technique is called circuit switching. So if this telephone is your telephone and the right one is another receiver, then the switches will establish a path between these two ends. When a call passes through a switching office, a physical connection is established between the line on which the call came in and one of the output lines, as shown by this dotted line. This dotted line means the switch will establish a temporary jump cable to connect these points to establish a path. The basic idea is once a call has been set up, a dedicated path between both ends exists and will continue to exist until the call is finished. An important property of circuit switching is the need to set up an end-to-end path before any data can be sent. So there will exist a long delay of established. The elapsed time between the end of dialing and the start of ring can easily be 10 seconds. More on long distance or international calls. During this time interval, telephone system is hunting for a job, hunting for a path, hunting for a path. Okay. Hunting for establish a path is establish a path between the two ends. Then the subfigure A illustrates the timing of events. Subfigure A illustrates the timing of events of circuit switching and the packet switching. From this figure, it shows the packet switching has shorter delay. For example, from the first bit of the message, this is first the message. Okay, for example, here, this point is time equals 0. Okay, this is the first bit of the message. This is the t equals 0. Okay, this is the first bit of the message, and the data, the amount of the data usually is equal. Okay. In the circuit switching, switches will establish a path. So from this point to this point, from this point to this point, the delay, this time interval is used to establish a connection. So from this point, the sender begin to transmit the data from the sender to receiver. So this is the beginning of the transmission. This is the time when finished transmitting. So the total time is from this point to this point. But for packet switching, we know from this point, then the last bit arrived at the receiver. So the delay is from this point to this point. So they are different. So circuit switching, the time interval is used for establish a path. But for packet switching, packets are sent as soon as they are available. Packets are sent as soon as they are available. There is no need to establish. There's no need establish a path. So there's no need to set up a dedicated path in advance. No need. Unlike with circuit switching. So they are different. It is up to routers to use store and forward transmission to send each packet on its way to destination or its home or on its own. Now, this procedure is unlike circuit switching, in which the result of the connection setup is the reservation of bandwidth all the way from the sender to receiver. All data on the circuit follows this path. Among other properties, having all the data follow the same path means that it cannot arrive out of order with the same reservation of the quantity of service argument. With packet switching, there is no fixed path, so different packets can follow different paths depend on network conditions at the time they are sent. So in circuit switching, packets arrived in order, while in packet switching, the packets may arrive out of order. We cannot decide which one is better. We know packet switching and circuit switching has different applications. For example, for traditional telephone, the circuit switching is used. But for computer communication, packet switching is widely used. Packet switching networks place a tight upper limit on the size of packet. So packet switching usually defines a maximum size of packets. Y defines maximum size of packets. It ensures that no user can monopolize any transmission line for very long, so that packet switching networks can handle interactive traffic. So packet switching, why packet switching can handle interactive traffic? An important aspect is it limits the size of packets, usually several hundreds bytes or 1,000 bytes of packets. Packet and circuit switching also differ in other ways. Because no bandwidth is reserved with packet switching, packets may have to wait to be forwarded. It introduces twin delay and congestion if many packets are sent at the same time. On the other hand, there's no danger of getting a busy signal and being unable to use the network. Thus, congestion occurs at different times with circuit switching and packet switching. At different times, for example, congestion may occur at setup time for circuit switching, but congestion occurs when packets are sent for packet switching. So if a circuit has been reserved for a particular user and there is no traffic, its bandwidth is wasted because this bandwidth resources is reserved for a particular user, but this user has no traffic to transmit. Then the resources will be wasted. It cannot be used for other traffic. But for packet switching does not waste the bandwidth, and thus is more efficient for a system perspective. Because computer communication has burst traffic, not a constant traffic. So packet switching will have a higher efficiency. Packet switching is more fault tolerant than circuit switching. So this page tells that packet switching has advantages than the circuit switching. The differences are summarized in this table. Circuit switching has dedicated physical paths. That means bandwidth resources of a physical path is assigned to a particular user. This is it has advantage and disadvantage. Advantage means dedicated physical paths will make sure that the user has a specific quantity of service. But on the other hand, if this user has no traffic, then the resources will be wasted. So the dedicated physical path has an advantage and also disadvantage. Each packet follows the same route. It is definitely advantage. Because every application expect the packets arrive in order. So each packet follows the same route and arrive in order. Usually, it is definitely advantage. So this is a circuit switching. It's better. Okay. Is a switch crash fatal? A switch crash fatal. That means in circuit switching, there is a key switches. So if a switch crashed, then the network will be splitted. It is a disadvantage. Okay, let's have a rest. Let's have a rest for 10 minutes. Let's have a rest for 10 minutes. Please keep connection. Okay, let's continue. This figure illus- illustrates the differences between circuit switching and packet switching. Okay, we should analyze each point. For example, core setup, physical paths, same route, and packet arrive in order. A key switching point, bandwidth available. Bandwidth available is fixed for circuit switched, but bandwidth available is dynamic for packet switching. Which one is better? No, we cannot decide which one is better. We cannot determine which one is better. Why? For circuit switching, the use the dedicated physical path. So the bandwidth available of the path is also fixed, but the resources will be wasted if the channel is idle. So fixed and dynamic. Dynamic means the dynamic means packet switching has a higher efficiency of bandwidth resources. Potentially wasted bandwidth. Potentially wasted bandwidth is related to the dedicated physical path and bandwidth available. For circuit switching, wasted bandwidth, yes, but packet switching, potentially wasted bandwidth is no. Possible congestion occurs at different times. For circuit switching, possible congestion occurs at setup time. But for packet switching, at every packet has meeting time. Store and forward transmission, then circuit switching does not adopt store and forward, but packet switching use store and forwarding. For circuit switching, when there is a dedicated path between these two ends, then it looks like there is a physical channel or physical cable between this end. So there's no need for store and forward. Charging circuit switched the service of circuit switching charged for per minute or per hour, per day, per month. But packet switched the charging is based per second per per packet. Then about the mobile phone systems, we will not talk in detail. Cable television using community antenna television was conceived in the late 1940s as a way to provide better reception to people living in rural or mountainous area. The system initially consisted of a big antenna on top of a hill to pluck the television signal out of the air. An amplifier called the hand end and strengthen it in a coaxial cable to deliver it to people's house, illustrated in the figure 50. This is an early cable television system. The cable television system can be used for networking. Then the improved cable television is HFC, hybrid fiber coaxial system. The electro-optical converters that interface between the optical and the electrical parts of the system are called fiber nodes. Because the bandwidth of the fiber, this is a switch, is a hand end, fiber trunk. This is the fiber trunk here, fiber trunk. The bandwidth of the fiber is so much greater than the coaxial. The fiber nodes can feed multiple coaxial cables. Okay, and for chapter 2, we are expected to understand these points. First, transmission media include guided transmission media, that means wired transmission media and wireless transmission media. Then we should understand digital modulation and multiplexing. So this is the key point: guided transmission and wireless transmission. Then the second point we should understand where is digital modulation and multiplexing. And the other, okay, this is the first. This is the third. So the theoretical basis of data transmission, we should understand Nyquist theory and Shannon theory. Nyquist theory and Shannon theory. So there are main 3 points we should understand where: data communication, transmission media, and modulation and multiplexing. Multiplexing includes TDM, time division multiplexing. Okay, and FDM, CDM, and WDM. FDM, TDM, FDM, CDM, and WDM. And the transmission media. Then the first one is we should memorize two equations. Memorize the two equations. The first equation is next theory. Next theory tells us maximum data rate equals 2b times log 2v. Here B is bandwidth, V is the discrete level of signal. So 2b times log 2v. The second equation is the Shannon theorem. Shannon theorem is a maximum number of bits per second. That means the maximum data rate. The maximum data rate unit is bits per second equals B times log 2 1 plus SN ratio. So we should memorize these two equations. Okay, then we should talk about the homework 1. Homework 1 is for the chapter 1, the introduction. So you are expected to submit the homework 1 in 2 weeks. Okay, in 2 weeks. So the deadline will be March 25th. March 25th. The deadline of homework 1 is March 25th. It's very easy. For example, the total number of direct links between nodes in a fully connected network with n nodes is which one? The total number of direct links between nodes in the fully connected network with n nodes is C. Why? The fully connected is C and 2, right? C and 2 or N2, right? So the total number of directed, that means, for example, n equals 2, we need 1 line to connect them. If n equals 3, we need 3 lines is needed. C 3, 2, right? If there's 4, they are fully connected is we need 6 lines. So the question 1, the answer is C. The network that operates within a single building, like a home, office, or factory, is called a LAN, right? Network operates within a small area, like a home, office, or factory, is called a local area network. Local area network, right? Then third, the question three, which one is the answer? Which one spans a large geographical area, often a country or continent? Yes. D. When wide area network spans a large geographical area, often a country or continent. Then computer networks are connection of autonomous computers. Two computers are said to be interconnected if they are able to exchange information. The distinction between a network and a distributed system lies with the software, especially operating system, rather than with the hardware. Lies with the software rather than with the hardware. This distinction between a network and a distributed system. Question 3. Broadly speaking, there are two types of transmission technology that are in widespread use: point-to-point links and broadcast links. Point-to-point links connect individual pairs of machines. Broadcast systems usually also allow the possibility of addressing a packet to all destinations. Some broadcast systems also support transmission to a subset of the machines, which is known as a subset of the machines, which is known as multicast, means point-to-point broadcast multicast. Question 4. According to the communication distance, computer networks includes local personal area network, local area network, metropolitan area network, and wide area network. To reduce networks design complexity, most networks are organized as a stack of layers and levels, each one built upon the one below it. The number of the layers, name of each layer, the contents of each layer, and the function of each layer differs from network to network. Basically, what is agreement between the communicating parties on how communication is to proceed. Protocol is an agreement between the communicating parties on how to communicate. Question 6. What defines which primitive operations and services the neural layer makes available to the upper one? Interface defines. Interface defines. Question 7. A set of layers and protocols is called is called what? It's called a network architecture. It's called a network architecture. A set of layers and protocols is called network architecture. The specification of an architecture must contain enough information to allow implementer to write the program or build the hardware for each layer so that it will correctly obey the appropriate protocol. So a set of layers and protocols is called network architecture. A list of the protocols used by a certain system. One protocol per layer is called a protocol stack. It's called a protocol stack. Question 8. A list of the protocols layer by layer is called a protocol stack. Question 9. The OSI reference model has 7 layers. Short answer questions, then you should read the textbook. Question 1. Please describe the difference between OSI reference model and the TCP/IP architectures with layered structure graphs. The necessary words. Question 2 is in the communication system with n layers, m bytes messages is generated by an application process. Assume that the head length of each layer is h bytes. Please determine the utilization of this system. So, okay. Please finish this homework before March 25th. Okay. And submitted to my email box. Submitted to my email box when finished. Okay, then we will continue the next chapter. Okay, then we will continue the next chapter. Data link layer. The data link layer is the second layer of network architecture. We will study these points: data link layer design issues, error detection and correction in elementary data link protocols, sliding window protocols, and example data link protocols. I don't know whether you have textbook. If you have no textbook, I can probably you can download electrical textbook from internet. For example, this is chapter 1, introduction. Probably you can read the electric version of the textbook. You can download from the internet. And it's chapter 2. It's a physical layer. Physical layer you can read the textbook from the internet. So we have introduced the next theorem and the Shannon theory. Now we will continue the data link layer. Data link layer is the second layer of the OSI reference model. In this chapter, we will study the design principles for the data link layer. This study deals with algorithms for achieving reliable, efficient communication of whole units of information called frames, rather than individual bits as in the physical layer between two adjacent machines. So the units of information transmitted in the second layer called frames, rather than individual bits in the physical layer. So the data link layer uses the services of the physical layer to send and receive bits over communication channels. It has a number of functions, including the following points. Function 1 is providing a well-defined service interface to the network layer. Function 2 is to deal with transmission errors. Function 3 is to regulate the flow of data. Regulate the flow of data so that slow receivers are not swamped by the faster senders. So there are 3 functions of data link layer: providing a well-defined service interface, dealing with transmission errors, that means error detection and error correction, then the flow control, right? Regulating the flow of data means flow control, so that the slow receivers are not swamped by the faster senders. To accomplish these goals, the data link layer takes the packets it gets from the network layer and encapsulates them into frames for transmission. In this chapter, we will talk about based frames. Each frame contains a frame header. Each frame contains a frame header, a payload field for holding the packet, and a frame trailer, as illustrated in the figure 1. Frame management forms the heart of what the data link layer does. Frame management forms the heart of what the data link layer does. This figure shows the relationship between packets and frames. Packets will know, for example, packets usually, this is layer 3, network layer 3. It's layer 2, data link layer. So packet is the unit of information in network layer. Frames, this is the frames. Frames is the unit information transmitted in the data link layer. So that is the relationship between packet. What's the relationship? The packet will be delivered to the data link layer, and the packet, the information in the packet, the whole packet will be encapsulated in the payload field. Will be encapsulated in the payload field. Okay, encapsulated in the payload field, and then the header and the trailer will be added to the frame to form a frame. That is the relationship. So frame contains the packet as a payload field. So in the data link layer, we will talk about the principles around these 3 points: well-defined service interface, and the error control, and the flow control. Okay, three points: 1, interface; 2, error control; 3, flow control. So we will talk about the flow interface and error control and the flow control. So we will continue the next time. So much for today. Bye.